the value of the integral, cyclic integral 6z by 2z power 4 minus 3z cube plus 7z square minus 3z plus 5 into dz evaluated over a counterclockwise circular contour in the complex plane enclosing only the pole z is equal to I, where I is the imaginary unit is. So let us consider the given integral as I is equal to cyclic integral 6z by 2z power 4 minus 3z cube plus 7z square minus 3z plus 5 into dz. Now let us consider the denominator as fz is equal to 2z power 4 minus 3z cube plus 7z square minus 3z plus 5. Given that z is equal to I is a pole, substituting in the denominator function f of z, we get f of I is equal to 2i power 4 minus 3i cube plus 7i square minus 3i plus 5. We know that I square is equal to minus 1. That implies f of I turns out to be 0. Therefore, z is equal to I is a singular point. Now, the given integral I can be found out as 2 pi I into residue at the point z is equal to I. In this equation, first thing is to find out the residue at z is equal to I. Residue at z is equal to I is given as limit z tends to I, z minus I into 6z by 2z power 4 minus 3z cube plus 7z square minus 3z plus 5. Now multiplying z minus I and the numerator 6z, we get residue at z is equal to I is equal to limit z tends to I 6z square minus 6zi by 2z power 4 minus 3z cube plus 7z square minus 3z plus 5. Substituting z is equal to I in this right hand side of the residue, that turns out to be a 0 by 0 form. Therefore, we need to apply the L'Hospital's rule where the numerator and denominator in the limit are differentiated separately. Upon doing that, we get residue at z is equal to I is equal to limit z tends to I 12z minus 6i by 8z cube minus 9z square plus 14z minus 3. In this equation, if we substitute z is equal to I and I square is equal to minus 1, we get residue of z is equal to I as I by I plus 1. Recalling, we have the given integral as I and that was written as 2 pi I into residue at z is equal to I. Now, in the right hand side, substituting residue at z is equal to I as I by I plus 1, we get the value of given integral as 2 pi I into I by I plus 1. Rationalizing the denominator, we get the given integral as I is equal to 2 pi I square by 1 plus I into 1 minus I by 1 minus I. Upon simplification, the value of integral turns out to be minus 1 plus I into pi. The correct answer for this question is option A.